Okay, let's do some more with section 3.7. I'm gonna breeze through the beginning of this section because it's pretty self-explanatory. It follows along with section 8.4 very easily. That's why I'm doing this section with 8.4. So here we're looking at absolute value functions, and we're looking at vertex form of an absolute value function. So the only thing that's different about the graph is that it looks like a V instead of looking like a U. And the only thing that's different about the equation is now instead of it being x squared, now it's the absolute value of x, which makes it a bit different. So when we do our absolute value functions, it's almost the same idea as our quadratic functions. So I just want to point out in example 1, let's go through this example quickly here. So if we were to graph this function, absolute value of x plus 3, I would start off by finding the vertex. So the vertex, there is no h because there's no number being subtracted from here inside. So it would be 0, and then our k would be 3. Notice how that goes in the middle of our table. We go 2 numbers down and 2 numbers up, and then you find your y values, and you draw your V-shaped absolute value function. Look at letter B, absolute value of x minus 2. Remember that the h value is after the minus sign, or the opposite of what you see here. So the h is really a positive 2. Then the k is what's added at the end. This one doesn't have a k, so our k is 0. So our vertex, look at this table, is 2, 0. Then you're going to go 2 numbers down and 2 numbers up and make your graph, and your graph is over here to go along with it. When you're talking about the comparison to the parent function, remember what the values mean. The k tells us about a vertical translation, so this plus 3 tells us it's a vertical translation of up 3. And the h tells us about the horizontal translation, so this is a horizontal translation of right 2, because remember this is a positive 2 for the h, so it's going to go to the right 2. Okay, let's take a look at example 2 quickly just to remind you of what's going on here. So in example 2, they introduced the a in the front. So if we have our a value in the beginning, think about how you would graph it. There's no h, it would be 0. There's no k, that would also be 0. Look how 0, 0 is in the middle. They go 2 numbers down and 2 numbers up and find their y's. If you think about the graph, if the a value is bigger than 1, this is going to be a vertical stretch by a factor of 2. Let's talk about the second one. Negative 1/2 times the absolute value of x. Again, the h is 0 and the k is 0. So I'm just going to look down here. Our t-table has 0, 0 in the middle, 2 numbers down and 2 numbers up, and you find your values here. If you don't want to have these fractions in your t-table, you could go by 2s, but it doesn't matter, they didn't care. And then look at how their graph looks. Because our a value here, 2 things. The a value is negative, so that's why our v, our absolute value function, is facing down. So it was reflected over the x-axis. And it's 1/2. Forget about that negative sign, just look at the 1/2. Since that 1/2 is between 0 and 1, this is a vertical shrink by a factor of 1/2. So that's just a quick reminder of those simple pieces here. Okay, I'm going to skip ahead to look at example 4, where we're going to put it all together. And I just want to show you the notes that I have down here. If you want to pause the video quickly, maybe copy down these notes so that you can refer to them. This is our absolute value function in vertex form. Y equals a times the absolute value of x minus h, and then plus k. Remember that the x equals h is our axis of symmetry, and our vertex is the point h comma k. So let's take a look at example 4. I'm doing example 4 from section 3.7. And I'm on page 159, in case if you want to look. Page 159. We are going to describe the transformation, and then we're going to make the graph. So it doesn't matter if you make the graph first or you do the transformation first, whatever you prefer. Why don't we do the transformation first, because that's what they said first in this problem. All right, so first let's talk about our transformation. In our equation, let's identify our A, B, and C. So our A value here is -2. Sorry, I meant our A, H, and K. Our A is -2. Our H value is in the absolute value bars here, but be careful, it's the opposite of this, so it's really a +1. And then our K value over here is 3. So I can even write that down here. Our A is -2, our H is +1, and our K is +3, if that helps you to write it out. Okay, let's describe our transformation. The first thing I can say about A is that it's negative. When it's negative, this is a reflection over the x-axis. So that means our V is going to point down. The second thing that I'm going to talk about for our A is the value of A without the negative sign. So I'm just going to talk about the 2 now. So since this 2 is bigger than 1, this is a vertical stretch by a factor of 2. Okay, next up is our H value. Our H is +1. Again, it's the opposite of what you see here, or after the minus sign. And if our H is +1, remember H is for the horizontal translation. And it's positive, so we're going to go to the right 1. Finally, our K value is 3, +3. The K tells us about the vertical translation. And if it's positive, we're going to go up 3. And that's our answer for part A. That's describing the transformation, all of the pieces that are happening here. Okay, our next step is let's make the graph. So when we graph it, I'm going to make a t-table with x and y. I'm going to have 5 spaces here, and I'm going to put the vertex in the middle. Remember that my vertex is h, k. My h is 1 and my k is 3. So let's put 1, 3 in the middle of my table. Now I'm going to go down by ones, so 0, -1, and up by ones, so 2 and 3. Let's get these y values, and we can get these y values by just taking the x's and plugging them in by hand, or we can use our calculator. I'll show you how to do that in a second. So let's plug it in. -1 minus 1 is -2. The absolute value, +2, times -2 is -4, plus 3 is -1. Let's plug in 0. 0 minus 1 is -1. The absolute value is +1, times -2 is -2, plus 3 is +1. And then remember, the other numbers should just be symmetric. So this should be +1 and this should be -1. Okay, let's double check this by using our graphing calculator. Okay, go into your graphing calculator. I'm going to show you how to do this. We're going to go to y equals, and we're going to do -2. Now we need to get to the absolute value. So we're going to hit math. Then go to the right, get to number, and it should be the first option here, ABS, that stands for absolute value. So hit number 1. Now mine's an older calculator, so it just says ABS, but if you have a newer calculator, it should actually come up with the absolute value bars. So now we're going to type in x minus 1. For mine, again, it's older, so I have to close the parentheses, but if yours is newer, you have to hit the right arrow to get out of the absolute value bars, and now plus 3. Okay, so I just want to write down what we did to get to that absolute value bars. Remember, we did math, right arrow to number, and then number 1 is absolute value. Okay, so I'm just going to write that down here so that we can have it in our calculator. So for our graphing calculator, you go to math, and then right to number, and then you pick number 1, which says ABS, absolute value. Okay, let's go back and let's do second table, and let's see if we got the numbers that we want in our table. We're going from -1 to 3. So I got -1 is -1, 0 is 1, 1 is 3, 2 is 1, 3 is -1, and that's exactly what I got here in my t-table. All right, so now I'm ready to make my graph. Let me grab my graph paper. And I'm gonna draw my coordinate plane. Okay, let's plot these points. We have -1, -1, 0, 1, 1, 3, 2, 1, and 3, -1. And now this graph is a nice straight V. So I am going to use my ruler here and draw a nice straight side from the vertex out to the left, put an arrow at the end, and from the vertex out to the right and put an arrow at the end. And look at that, that's our absolute value function. We can check our graph in our graphing calculator. Let's hit graph. And yep, our graph looks exactly like our graph on graph paper. And let's just double check, does the graph actually match with all of the transformations that we set up here? Look, this graph is definitely pointing down, so it is a reflection. And then was it vertically stretched by a factor of 2? Yeah, look at the slope of this side. This is a slope of up to right 1. Normally the V has a slope of 1, but this V has a slope of 2, and then this side is -2. So yeah, this is a vertical stretch. It's more narrow. Okay, look at where the vertex is. Our vertex is to the right 1 and up 3. That's what we said here, right 1, up 3, so it does match. Okay, I hope you found this helpful to do your 3-7 review assignment in preparation for our test.